Okay, now that we have moisture in the clouds, up in the atmosphere, what are we going to do with that moisture? Well, we all see cloudy skies or clouds appearing or some type of precipitation forming. So how does this all happen? What makes it work? So we'll take a look at that. The water vapor is invisible. You can have water vapor in the you have water vapor in there all the time. And if it doesn't have it hasn't condensated yet or deposited on product, it's not visible. So clouds are a visible manifestation of that. That means that something happened to cause condensation of water vapor. On average, about 67% of the Earth have clouds. So take a look at a water droplet. This is not quite the scale. Actually, the water droplet in a cloud is smaller even than what is appearing here compared to the size of a water droplet, a rain droplet. So the initial size of a cloud droplet is really, really tiny. So what happens when it's really tiny? Well, instead of being a nice flat surface of a water, like a pond, we have a very curved surface. When you have a curved surface of water, it's much, much easier for the water molecules to go back into a vapor rather than stay as a liquid. So what happens is you need a tremendous amount of saturation to keep a tiny, tiny water droplet available there. The stronger that curve is, and in very, very tiny water droplets, it's very, very big. Whereas if it gets much bigger, maybe the size of a raindrop, it starts approximating more like a flat surface. But when it's very tiny, this is called the curvature effect. What it basically means is that if you don't have anything else in the atmosphere helping it, in order to form a little tiny droplet to make a cloud, you need to have saturations over 200 to 300%. We don't get that. So there's something else that's got to be going on here. What is it? There are hygroscopic nuclei, condensation nuclei. They could be things like dust. They could be dirt. They could be salt from the sea, maybe pollution from a factory. But whatever they are, those little tiny droplets that begin to form, this condensation nuclei literally dissolves in them to make a solution. And that solution then holds that water, that little tiny droplet together. So that is how the water droplets form in the clouds. You need both saturation and some condensation nuclei to form it. So this allows the initial growth to start, and as the droplet continues to grow, the solution gets less and less, so you don't notice it as much. But that initial solution is needed to get the water droplets to form in a cloud. Now, there's also something called ice condensation nuclei. You see, these water droplets don't freeze. They're tiny, so they have a lot of kinetic energy still in them, so that when it's trying to freeze, when there's no ice forming nuclei there, they don't. They wind up not freezing till it gets way, way cold. So you get super cooled water vapor, super cooled water. But because we have ice forming nuclei, again, not necessarily that undifferent than what we have for condensation nuclei, just slightly different chemical makeup, they allow the water to freeze. They'll begin to start forming ice at around -degrees Celsius and really become fully active by -20 degrees Celsius. So there will be supercooled water in a cloud, but when the ice crystals start forming, they begin to change that water over to all ice. Precipitation. An ice crystal, a snowflake, gets big enough that the friction of the air and the air pressure pushing upwards on it is overcome by gravity and the weight of that parcel, and it begins to fall back to Earth. So what processes make these precipitation? Well, one of them is collision coalescence. It happens in a warm cloud. That means temperatures usually are above freezing. So let's take a look at it. What happens is one water droplet, this grows a little bit bigger and begins to fall down. What happens is it hits a whole bunch of other water droplets as it's falling. When it does that, it forms a bigger and bigger raindrop, literally, until it reaches the ground. So that's collision coalescence. So collision is hitting another tiny water droplet. Coalescence is putting them all together into a bigger and bigger droplet. The main way precipitation forms in clouds, because most clouds are below freezing, is Bergeron-Findeisen. So let's look at that. An ice crystal forms. Something triggered an ice crystal. Now, remember, saturation vapor pressure over ice is lower than saturation vapor pressure over water. So that means that the water is going to tend to flow. That vapor pressure is literally caused the pressure gradient that will flow from the liquid to the solid. So the ice crystals will tend to grow. And that's where the snowflakes come. Even though you have super cold water, they begin to flow into and generate these snowflakes that are big enough to fall down. And as they're falling, they may evaporate like Virga does. You know, if the temperature is warm enough and the dew point is low enough, you get relative humidity is very low. You see this a lot. There are different types of precipitation. There's rain and drizzle, which are really very tiny raindrops and drizzle, bigger ones in rain. Snow. One of the things I wanted to show you in snow, and it kind of messes up the forecast, is see what they call dendrites. Forms between -10 and -20 degrees. However, if the temperature in the cloud where the crystals are forming is a little bit below that, they're more these prism shapes. Or if it's a little bit colder, they're a little more columns. Think about it. This snowflake, the dendrite, which is what most snowflakes are, is a lot bigger and a lot more airspace in it. These other ones have a lot less airspace. So if I were to put down 3 or 4 inches of snow from dendrites, it's going to have a lot less water to make it to that point than if I did 3 or 4 inches of these more prism shapes. So that is something that a meteorologist is always looking for. What type of snowflake are you going to have to determine maybe how much snow you're going to wind up getting? One of the interesting things, and it happens all the time in winter, and you've had it this past winter, we've had it around here, is that, yes, most of the precip begins as snow. But many times a warm layer comes in aloft, and it doesn't take much, and that melts the snow. And then, when it goes underneath it, if there's enough freezing air there, it will freeze back into sleet. If there's not, it'll just be freezing rain at the surface. Now, if it never melted, it stays all snow, or if it melted all the way and becomes all rain. So you can see, depending on the temperature of the air aloft and how thick that warm layer is, and it doesn't take a lot of warm layer, it can cause the precipitation to go anywhere from snow to sleet to rain to freezing rain. So radar is another way of looking at precipitation and clouds and dust. Actually, we can detect bugs along front sometimes with radar. So there are 2 different modes of it. Reflectivity mode, which is just detecting the precipitation, or something is getting reflected back. And then there's velocity mode, which detects the air motion directly, whether it's away or towards the radar. And there's a radome, and you got to walk all the way up to the steps to get up to the radome and see it rotating inside. But the Doppler effect, as it shifts, can tell you the speed to or away from the radar. And here's just a picture comparing the two. Reflectivity mode, you can see the more intense the precipitation, the more bigger the droplets are, the closer together they are. It's looking redder, whereas lighter precipitation is closer to green. And right in here, there's actually a little tornado. And there's a little tornado debris signature. So actually picking up debris from the tornado that's being seen. And that is more of a dual Doppler. Dual pole Doppler can pick up debris from a tornado and actually determines the type of precipitation you get. The one advantage of dual pole over almost anything else that we ever had before is it looks at precipitation shape. So it can determine whether the precipitation is more liquid or solid, or whether it's hail, the size of the shape. So we're actually able to pick up hail now, much better. We're actually able to pick up some debris in the clouds that may have formed from the Doppler. Phased array is a futuristic radar. I got to play around with it on an experiment I got on for a while out in Norman. And only at Norman is there one that the Weather Service can use. What it is a regular radar, but it's just operating continuously in all elevations. Radar, that dome, that thing you see rotating, actually goes up as it rotates and then rotates back down. And that's how we get to see what's going on in the whole atmosphere. With phased array radar, it's looking in every direction at once, and that's the big difference. We have no phased array radar right now. Another thing radar can do, especially dual pole, is give you a rainfall. Clouds, we classify them basically on cirrus, high wispy, stratiform or more layered, cumulus clouds are more bumpy, and depending on the temperature is how they're going to impact that cloud. These are just clouds coming off the lake, where the lakes form the clouds. And fog can actually form over a lake. Like this case is Lake Erie, formed over the lake from the warm, moist air coming from the ground to the east, to the south, hitting the cooler water, forming a layer of fog, and then being advected out over. So I just wanted to show you a couple quick things here. This is some dual pole products. This is actually an area indicating there's a hail occurring. It's correlation coefficient. It determines how the precipitation is related. Basically, is the precipitation size the same? Which would be the case. Snow is especially all similar. Rain is typically similar, but this has ice right mixed with the rain. So this is looking differently. Differential reflectivity, again, looking at the shape. Here is a National Weather Service radar that may come up here in a minute. This is out of Billings, and I just wanted to get a quick peek at something here. And hopefully it'll show us real time what an image of whether it's snowing or not snowing. There was several tornadoes this past week, and I just wanted to grab one of them. You can actually see the dual pole mode. Here is the Doppler mode right here. You're seeing velocity, the two different velocities right next to each other. So there's a very strong rotation right here, and it's right underneath this heavier, darker precipitation. So hope you got all of that. Here you can actually see on this one, most of this is light snow actually falling right now out here, and right in around Billings is pretty much ground clutter, picking up the ground. The Doppler is seeing that instead of the actual precipitation is very light in that area. So I hope you got something out of this. No, don't hesitate to ask me any questions.